afternoon, everyone. I'm Shravani Dikshit, and here is my co-speaker Ayush Mishra. Today, we are here to take you on a journey where we will be talking about local problems that affect real people and the global intelligence powered by cloud AI. So, we are in a turning point in tech. For years, AI had lived in huge research centers in GPUs that cost lakhs of rupees and an environment which is out of reach for most of the people. But cloud computing has changed that. You get automated flows, you get the what do you say, you get the compute, you get the storage just in the click of a single button. And this shift is important because anyone who doesn't have the infrastructure but has the idea can make use of it. For example, many companies are actually moving to the cloud to leverage its capabilities. For example, now the what do you say, the NASA makes uses of your AWS for the Mars rover analysis, and then you have your what do you say, WHO, who makes use of Azure AI to predict or to detect the outburst of diseases across continents. This is why it is said that AI lives in the cloud. It is important. For example, when you wanted to build AI frameworks before, you would need hours of data configuring the data pipelines. Then you would need the what you say, for feature selections, you would need to set up the deployment servers. But now that's not needed. AI cloud does something magical over there for you. It gives you the auto ML, which helps you to configure those pipelines or to automate your pipelines. Then even it gives you the serverless where you can run your ML workloads without actually touching the infrastructure. That is why it is said that you don't need to worry about the infrastructure, you don't need to worry about the hardware, you just need the idea to start your own idea, your own innovations. You move from your data to decision instantly. You have your serverless, you have everything. If you have the laptop, you have the internet, you can work on solutions which can create a real impact to the world. Why is AI moving to the cloud? There are four major factors which is driving this movement. First is the data explosion. We can't talk about AI without talking about the data, isn't it? Because there are huge number of sources from where you get the data. From example, your satellites, your mobile applications, your sensors, and where do you put that huge amount of data actually? Where do you accommodate that huge volume of data? You put it in the cloud. Then you have the compute scale. To build the email frameworks, you would need elastic compute and storage. The cloud provides you that, right? Then you have the third and most important thing, your cost. You know, the cloud runs on the pay as you go basis, right? So it drastically cuts down your AI infrastructure cost. Then the momentum or the speed, where actually cloud lets you move into regions within minutes, not months. This is why it is said by experts that by 2027, 60% of the AI workloads will be migrating to the cloud. What does cloud AI enable, or what does it actually give? It quite a lot actually. You get intelligence on demand. You have all your vision, speech, your translation models just a API call away. You have your auto email, which helps you train, tune, build your models. Then you have your serverless, which runs your workloads. Then secondly, you have real-time automation. As soon as there is a change in the data, your AI gets triggered, and you get an alert, right? And that's what is the impact of AI or cloud AI actually. Then you have your responsible AI. Since the clouds in any region are compliant to the government rules and regulations, you get, when you put your workloads, AI workloads in the cloud, you get something which is both trustworthy, reliable, and government audit compliant. That is what is the happens when you put your cloud workloads in your AI workloads in the cloud. Then moving on, the cloud AI providers, as usual, you have your top three cloud AI providers, your AWS, Azure, and your Google Cloud. These are some of the cloud AI functions that are provided by this top companies. First is for example, speaking about the cloud AWS SageMaker. It helps you train, tune, monitor your models. Then you have your Azure AI Studio, which helps you actually for all your enterprise-grade LLM orchestrations. Then you have your Google Cloud Vertex AI, which is used for your feature selections, for your AutoML, for your pipelines. And do you know your Google Cloud Flood Hub, which actually runs on this Vertex AI to predict floods 7 days in advance in across 80 plus countries. And this is what they offer you. They offer you analysis, they offer you personalizations, they provide you automation at a global scale. Now we spoke about what is this and what it is, but why do we actually need, why does the traditional ML, where does the traditional ML fail that we need such kind of solutions, right? So moving on, first of all, your traditional ML is slow, rigid, and definitely expensive because of the data cost. And then you have, for example, your hardware processing cycle in your traditional ML workloads take actually 6 to 8 weeks to configure. And then you have your GPUs, which run on 30% less utilizations. And then if there is no drift monitoring, if there is no automated drift monitoring, definitely your models will fail. And the increase, or there will be risk increase, right? And for example, if we have to give you an example, there are, during the COVID time, traditional ML models failed where they were not able to accommodate more than 10,000 concurrent users at the same time. And even during the 2018 Kerala floods, the traditional ML model failed. They were not able to predict the correct time of the flood due to not having the real-time data ingestions. This is why your traditional ML models actually fail. So since we got the overview why the traditional ML models fail, now we are migrating to many companies are actually migrating to this cloud native AI as solutions. And what does it give you? You don't need to worry about your DevOps. You don't need to worry about your servers. You don't need to worry about those frictions. You get everything in one platform. You get the compute, you get the storage, you get the automations, you get everything in just one platform, right? And who doesn't want that? And you get completely automated ML pipelines. You get the serverless, which does the workflow for you. You have your cloud builds. You have your GitHub Actions, which does the CI/CD part for you. You have everything in the cloud. Then why not make use of those services and run your workloads, your AI workloads on those? So that is why it is said that cloud democratizes AI. That is why many companies are moving to these solutions. So now let's get an overview or a high technical overview of any cloud AI solutions that is there within the market today. First, you have your data ingestions. The data comes from various sources like maybe your APIs, maybe your satellite data, your CSVs, your historical data, and those data are fed into any cloud storage. Then that data is pre-trained. It is trained using your AutoML, you have your GPUs on demand, you have your hyper-tuning parameters. That is all done by the AutoML models. And once your model is ready, you make it available for the end users by configuring it as a REST API. So any person globally can make use of that REST API and access your model services. Then last but not the least, your ML ops. Any ML services can't exist in the real world without this ML ops. You have ML ops provides you monitoring. It provides you the logs for your models. It provides you the drift detections for your models. And a very important thing that it provides you is your feedback loop. So based on the feedbacks, it keeps on improving your models. It keeps on doing the retraining, and you get a better model each time. So this is a universal architectural diagram. It's the same thing. Data from the sources fed into the cloud storage. Then you have the integration of it, you have the ingestion of it where you put it in your AutoML, your other services, and then it is being processed, the data is being processed, the ML models are being processed, trained, and then you have a serving where you actually get all those, you prepare a dashboard, you get a dashboard, where you get the real-time alerts, where you get the risk analysis and other things, and then you have your ML ops, which works on the feedback loop. So this is a universal architectural diagram for any cloud AI services which is available within the market. So since now we have gotten through the technical overview and understood what it is, now let's see the actual problem that we are trying to address over here. Many communities in India are facing urgent issues for which they have the idea, they have the knowledge how to tackle it, but they don't have something, that is the compute and the infrastructure. And how do they get it? From the cloud. And this story perfectly illustrates that. For example, here we have taken a story of a girl in a coastal region who is trying to help her community or her village by predicting the floods in advance. But she doesn't have the infrastructure, neither does she has the ML background to do so. Then what does she do? She makes users of this cloud AI services, because you don't need to touch things like TensorFlow, PyTorch, or such kind of complex parameters to make use of the services. She can just make use of the cloud AI service, and she can just call, by just doing the simple API call, she can build a framework which can help her communities. She does that. She uses the cloud AI services, weather APIs, the satellite imagery, the historical rainfall patterns, and the auto MLs helps her train the model. The serverless helps her run the workflows, and then she builds a flood prediction model which helps her entire community. And the consequence of this is really profound. She has not scaled the idea to only to her village, but to a very global audience, right? She has inspired many people to do so. And this particular solution is not only limited to any flood predicting system, it is to anyone who wants to build a system, let it be personalized learning system, let it be a healthcare system, let it be a climatic detection system. You can make use of this particular thing for anything. Cloud AI services are providing n number of services which many companies are actually making use of, and so does the communities. Combining all these capabilities of AI into three things. First is analytics. You get the analysis for climatic patterns, you get for the risk detections, you get for the anomaly detections, and then you have the personalized recommendation on the type of services that you want to actually build. Let it be education, let it be personalized pathways, or let it be for any senior citizen kind of services that you want to build for their welfare. And then you have the automation of your workflows, of your alerts, of the task scheduling. It can be anything. And blending these three capabilities together, you get a cloud AI system which is powerful, which is scalable and adaptable as well. So this was the overall that was the overall problem statement that we were trying to address. Moving on, next, my co-speaker Ayush will walk you through the architectural solution deep dive of the problem. So over to you, Ayush.
Hey, so technically any cloud AI solution has got to have a data source, and there's got to be some ingestion, right? You'll be doing something with that data, and then you're going to present it through serverless REST APIs, and they're going to plug into some application dashboards and so on. There's going to be some MLOps, monitoring, retraining. It's managing your cloud for you. When we're talking about flood prediction, our data sources are of two types, two major components, weather APIs and satellite data. Weather APIs such as Google Flood Forecasting API, or there's even an IMD, Indian Meteorological Department. They've got their own set of APIs called IMD Nowcast. Essentially, they provide you with real-time and forecasted rain patterns, right? They tell you about humidity as well, two very major parameters for the prediction of flooding. And if we move to satellite data such as high-resolution imagery or Google Earth Engine data, we can take a look at how affected areas look before and after the flood. We can understand land elevation patterns again. So they comprise, both of them together form the data sources that we would need. Your data would flow into a cloud data lake such as your S3 buckets or Google Cloud Storage, right? And essentially here, you're going to store the raw data, and prior to training, you're going to clean this data such that it is, in a way, ready for your model to pick up, right? Now, this clean, reformed data is sent through to feature extraction, which in our example, can look like, rainfall grids that you can picturize on a map, right? You can pick those up. Soil type and wetness, elevation. These are all data that you can use as predictors. Like you're going to try to form predictors off of them for your AutoML models to pick up and retrain and help you with your predictions. AutoML models can be AWS Lambda or Google Vertex. And essentially what these would do is they would train and retrain a series of classification and regression models. And essentially a classification model is going to kind of give you a 1 or 0 result at the end. So your classification model can look at if there is going to be a flood or not, and your regression models can predict risk zones and timelines, right? Risk zones and timelines can also be visualized on maps, and these timelines are generated upon hourly, daily, and weekly predictions. Now, we're here where our serverless functions, such as Google Cloud Functions, would help in, let's say we've got to send out alerts to local residents and to the authorities. So these serverless APIs are what are going to help us do that. And you could also maintain a public dashboard that's going to give the end user a lot more of reading. So maybe groundwater levels and things like that. But the public dashboard actually does a lot more than just visualize data, because it's going to help in what is called the feedback loop of the model, because the people closest to the problem are going to be the ones who are working with it. So instead of just any other developer retraining it or figuring out what other parameters could go into it, that's what the public dashboard would do. Based on your requirements, there are 4 integration patterns that you can use. One is event-driven ingestion. So event-driven ingestion is when you want real-time updates of something. Let's say event A has occurred here, and I want to know how my prediction is affected by this. So I would set up an event-driven ingestion there. Like I said, it happens in real time. Batch pipeline ingestions are for periodic updates of it. So let's say your model's retraining or your model's reporting of what is going on can happen over batch pipelines. Now, hybrid cloud and plus edge technologies are used when we're working in areas of really low bandwidth, low bandwidth. And multi-cloud solutions help you to pick and choose the best services from each provider so that your solution is as robust as you would want it to be. All right, we're going to head into the summary, and we're going to look at how cloud AI is going to solve a few problems that Shabnia and I have listed. One is that cloud AI really makes AI accessible to a lot more people than it usually than it was. So it doesn't really have to stay stuck to a lab, right? And even though you and I, as normal citizens, can go ahead and access this, we still do enjoy enterprise-grade security and access control, encryption, and all of that. It is given to us out of the box in these AI cloud solutions. Now, when you're using AI cloud solutions, you will probably use AutoML models or serverless compute, and this would help you, drastically reduce your delivery time. And it actually helps developers to just go ahead, deploy, test, figure out if what they've done is working, or just take it back. Whereas any other day, I would probably have to go through a lot more of model building and resource collection and things, right? So there's always going to be a cloud ML ops, which will retrain, monitor, and self-optimize models as newer data would flow in, right? And with cloud AI solutions, your APIs, sensors, applications, everything is kind of connected through event streams and APIs. What that does is people don't really need to have their own supercomputers for them to provide a solution. You can just borrow global resources and have your solution riding on top of it. So the shift in the AI world that would be now seen is that local problems ride on top of global resources. So you don't really have to worry about what you have, but you can focus solely on what you want to achieve. All right, so there are a few key takeaways, like we've already mentioned. Innovation without infrastructure is at the heart of cloud AI. Three frameworks that I would leave you with is analytics are for when you want to understand patterns. Personalization is for when you want to tailor experiences to an end user. And automation helps with operationalizing a lot of actions at a large scale, right? And through everything that was mentioned, responsible AI is a must-have. So it's got to be fair, transparent, and it's got to be following all governance, right? The vision forward would be that anyone, students, teachers, NGOs, innovators, anyone can use cloud AI, and it can be used to solve problems of communities without resources, as well as something you want to probably solve for yourself. Thank you. And if anything from this has resonated with you, I hope you can go back and try to see how a problem of yours could, could make advantage of a cloud AI solution. Yep. Thank you.